At the end of lecture part 1, we were saying for a volume of solid of revolution, we could use cylindrical shear metal, we could use sometimes disc metal or washer metal. Now, in general, the cylindrical shear metal is a little simpler algebraically. Let's look at this graph again. So we pick up a vertical strip to revolve. The revolution of this strip is a shell, so we come up with the shell formula, dV, just for comparison. Alright. Now, the same problem, say, if we pick up a horizontal strip to do it, then the increment will be dy. Revolution of the strip, like we did before, is a washer. Then you know the formula is going to be pi r out square minus r in square, and this is dy. So as you can see, just algebraically for comparison, if you go with the washer approach, algebraically the square of r out square of in could be more complicated than just simply product of r times h. That's the only difference. But there are times because of the region, because of the border of the region, can be more complicated. So one method can be more complicated than the other. So it's hard to tell just to compare the formulas. Those are just what we see by comparing the formulas. Algebraically, this is a little simpler, but there are other factors that could affect our decision which way to go. So we have to know both methods. Alright, now I wanted to do one more example. Okay, again, of course, this section we're focused on the cylindrical shear metal, so we're going to use that method again. Find volume of the solid generated by rotating it around the line x equal to 3, a vertical line x equal to 3. The region bounded by the graphs of y equal to x to the third power, y equal to 0, and y equal to 2. So there's a region. It's going to be revolved around line x equal to 3. X equal to 3 is a little more toward the right side of x-axis. Because of this, I realize I better have more room on this side so we can see the graph, see the revolution. If you can realize this before you set up the coordinate system, just better. If not, you start to draw your graph in a coordinate system, you arbitrarily pick it up and you realize, well, I don't have enough room. You can always do it again. Just make sure you get enough room to graph, enough room to label involved lines, curves, positions, right? So let's start to graph. Y equal to x to the third power is curve like this. y equal to 0 is x-axis. X equal to is, say, let's just vertical line. Now x equal to 3 would be approximately here. See, I got a lot of room for the graphs to sketch, and also the revolution will do. Okay, now we see region. Y equal to x to the third power, y equal to 0, x equal to 2. So those three graphs enclose region like that. We pick up vertical strip to rotate. Now immediately we need to indicate the location we pick up the strip. Consequently, the increment will be dx, thickness of the strip is dx. Now I can see the revolution of this strip. So rotate the top, rotate the bottom. Obviously it's a cylindrical shell. So volume of a shell is 2 pi r h dx, because a vertical strip is picked up. Don't need to memorize when to have dx, when to have dy. Once you start to graph, pick up a strip, then you can see whether it would intersect with x-axis or y-axis, or sometimes you may need to extend the strip to see which axis it would intersect with. Alright, so we got the shell, cylindrical shell. Now figure out radius r. Well, radius, like we talked about in part 1 of this lecture, don't mark the radius at the top or the bottom, mark it in the middle to avoid any possible confusion. Okay, so radius, as we see in the graph is essential. It's a horizontal distance. Horizontal distance, we need to figure out x at this end called xr, x at this end called xl, the right end, the left end. Alright, so what's the x expression or x value at this end? Look at the picture, it's x equal to 3, so it's 3. What's the x value at the left end? This is the left end. Well, it's x. That's why it's important to mark the position of the strip at x in this problem. So have 3 minus x as r. Now the height, as we can see, is the length of this strip, which is in red. That's a vertical distance, so we need to figure out YA, YB. There's two little formulas we always use in this kind of problem. Okay, YA is the Y spot here. Now we are looking for the expression in the form of y equal to 2. Just keep that in mind. Now first of all, this point is on the graph of y equal to x to the third power. So we identify the equation, the function, and this happens to be in the right form to y equal to, so just plug in directly. Y position at the bottom is 0 because it's on x-axis. Alright, so plug in. Simplify. Now you can see here too, with this shear metal, the algebra involved here is usually simpler. You multiply, it's a simple multiplication. Well, with the washer metal, you have to square a difference twice actually, because R out square, R in square usually is each is a square of difference. But anyway, so you simplify. Now add them up. So as we see, the strip would move within the shaded region from 0 to 2, the right end, to cover the whole region. So it's 0 to 2. Just find the antiderivative. That it's a 3. It's a 3 over 4 x to the 4th power and the 1 over 5 x to the 5th power. Then you plug in 2, plug in 0. With the calculator, it should be pretty easy to simplify the answer. 2 plug in and 0 plug in. This is 0, this is 0, so it's entirely 0, the second term. Alright, so this be the final answer, volume of the solid of a revolution. Okay.